So in this video, we're looking at another reason as to why we factorise. So we also factorise to find the intersection between two graphs. So we'll go through a couple of examples here, and then we'll see, and then hopefully we'll get an understanding of where this all leads to. So basically what we've got, you say we've got this graph, which is a parabola, x squared plus 5x minus 24, and then we've got another graph, y equals 3x plus 39, which is linear. So we're going to have some parabola, just draw this quickly, may look like that, I don't know, and then we've got 3x plus 39, I know it's going to kind of look like that. So we're trying to find those points there. What this will do, this will give us the x coordinates for these points there. For over here, hopefully you're seeing that we have two parabolas. So we've got this 2x squared plus 2x minus 10, which is going to look something like this. Draw that better. And then we're going to have another one which says x squared plus 7x plus 26, which may look something like this. So what we're trying to do is we're trying to find that point there of intersection. I'll draw that one better again. So we're trying to find that. There may be one, there may be two, we don't know. Just like with this one, there may be one, there may be two, we don't know. So we're going to see what happens. We're going to factor them. We're going to factor these, and that's what we're going to try and find out where these intersection points occur. So I'm just going to remove that because I'm going to need some space. Now, what we have to do for this is we've got to let the two equations equal each other, because we're trying to find where they are the same. So we're trying to find the common points they have, so we're trying to find where they're the same. So we're going to say x squared plus 5x. This is essentially solving simultaneous equations. Minus 24 equals 3x plus 39. So what we're going to do, we're going to bring everything over to one side. So we're going to bring all of this over onto that side, and we're going to let it equal 0. Or basically we're going to subtract 3x and 39 from both sides. So we'll take this 3x, bring it over to this side to make it negative 3x. So we'll have x squared, 5x minus 3x gives us 2x. And negative 24 minus 39 gives us negative 63. And now that equals 0. So now what we do is we factor that like we have done in the past. And I think I've made a bit of a mistake in terms of what I've done, in terms of my working out, but hopefully it won't matter too much. Anyhow, so what we're doing is we're looking for factors of negative 63 that add up to positive 2. So hopefully from there you come across this before, or you may be able to see it already, I don't know. So basically from there I know I'm going to have x plus 9 and x minus 7, and that still equals 0. So now from there I'm going to say that so for this to hold true, that has to be 0, or that has to be 0. If this is going to be 0, x has got to equal negative 9, and and x also has to equal 7 for that to be true. And now what we do is we take this value here and substitute it into, say, this one, and likewise this. We substitute it into this to find the y coordinate. So right now it's intersecting at x equals negative 9 and x equals 7. What we want to do, we want to find the y coordinate. We could substitute into this one, but that's a lot more work because we've got to deal with it twice, whereas here we've got to deal with it once. So then y will equal 3, 9 plus 39. So 27 plus 39 gives us, what's that, 66? And then as well as that, oh no, that should be a negative 9, sorry. Ooh, made a mistake of that. Should be a negative 9. So we've got negative 27 plus 39, that should be 12. And then for the other one, y equals 3 times 7 plus 39. So we've got 21 plus 39 to give us 60. So there are two intersects. So we can intersect at negative 9 and 12, and also 7 and 60. So I'm not going to draw because I'm running out of space. Okay, this thing here, we do it exactly the same way as what we've done here. So we let them equal each other. Hopefully we've got enough space. 2x squared plus 2x minus 10 equals x squared plus 7x plus 26. Plenty of space. There we go. Okay, so what we're going to do, we're going to take this, we're going to subtract this from both sides. So that we have 0 on the right, and on the left we will have 2x minus x squared. So 2x squared minus x squared, we're left with x squared. 2x minus 7x, so we've got minus 5x. Negative 10 minus 36, we get negative 36. And that equals 0. So now once again, we're going to factor it. We're looking for factors of negative 36 to make up negative 5. Hopefully we're seeing these already, and we're going to say, oh, okay, well that's got to be x plus 4, x minus 9, still equals 0. Because here we'll have x times negative 9 gives us negative 9x, x times 4 gives us 4x, negative 9x plus 4x, we get negative 5x. 4 times negative 9 gives us negative 36. So from there, we say that x equals negative 4 or x equals 9. So now once again, we take both of these and we substitute it into, I'm going to substitute into this bottom one because it's less to do. It doesn't matter. I'll substitute into the top one. So I'm not going to go there, I'm going to go into the top one. So we're going to say 2 by negative 4 squared plus 2 by negative 4 minus 10. So here we'll have 16, 32 minus 8 to give us 24 minus 10 to give us 14. So we're going to say 14. And we're going to substitute this 9 into here. So we'll have 2 and 9 squared plus 2 by 9 minus 10. 9 squared is 81. 2 times 81 is 162. 162 plus 18 gives us 180. Minus 10 gives us 170. So we're going to have intersection points of negative 4 and 14. And then 9 and 170. So that's what we do there. That's why we factor. We factor like we did in the previous season to find x-intercepts of a graph and also to find the x-coordinates of the intersection between two graphs. And this is the technique you can apply to any type of graph, any two types of graph in any situation.